Okay, first of all, a very good evening to all. I am Rajnikumar Sikhalia, RK. So basically, my background is I am B mechanical and working with the John Deere for 15 years, mainly on off-highway vehicle domain, structure design, cost reduction, and new product development. That is my background. And yeah, recently, means like last year, we were have fortunate to get training on trees and also the implementation of the trees. So let me put you that how we come up with the trees and things that got out. So after that during the COVID time, I think these our management started to give us a training on trees, and that was batch wise. And I think we have Sri sir and PVN. We just give us thoroughly, on the PV on the tools of the trees. We got means like almost before that what we were doing only the brainstorming and ideations, which will not lead us to the way we just want to get into the target or goal or some specific solution. So that was the thing we did. So what was the good thing about the training? We got the project and discussion on various topics on that how the trees would help and how it is different than other uh, tools or other methods we are using. So then one sentence that we called first that it is very systemic method which has a very robust background that any of the who taken the training knows that Mr. Alsular, who is uh, founder of this trees methodology, he has searched almost, if I remember correctly, 2 lakh patents, and then decide that what would be the innovation base. So for us, this would be a good journey started. So as I said previously, we were doing most of the conventional or what are the tools available, which would not benefited in that intensity. So how the trees helped us, it is uh, give you the insight, which is uh, you know uh, I can say the brainstorming and other thing is one direction, or maybe it is sometimes I can call it as a magic. So you people give the ideas and they know the background about what the surrounding system, while the trees will take care of all the aspect like relation. So basically it is the functionality base, so all the parts or all the system which we are touching, that needs to be analyzed for their surroundings. So if one part is let's say affecting, then what would be the surrounding parts would do. So this is how the trees helped us. Uh, the things, the tools we are methodology is like we have a function model, we have a interaction model. So that is a connecting system well. So that is a defined system well, and the other thing is a good thing about uh, it defines the system in such a way so that whatever the part system or subsystem you target, that will uh, be defined well. So uh, if one thing is changed, then the other thing would be taken care in way. And the uh, uh, the more like uh, how it helps in my project. So uh, let's say we I am from sugarcane harvester background, so we have a topper, so which is like uh, you know uh, a rotating drum kind of part, which is having cutting disc and pedals, the kind of parts that we have. So the target was the weight reduction, and then we tried the conventional way with, as I said, two brainstorming session and ideation. So we couldn't utilize, come out more on it. So we started with the trees project to address this target on this. We defined the system. Define the function model, so where the each part having the function, whether the that would have a, what kind of a ranking, whether the it is working where sufficient, or whether it is having less, so kind of that, those things, and their interaction. So while doing the part wise, then we go to the each part. So that is the beauty of these trees. It is not targeting, a single part or so. You have uh, liberty to go through the whole system, and where the change, or where the, system you, based on the defined goal, you will get, more close towards the result. So uh, that topper, that roughly I can say, due to some IP restriction, I could not share the picture, but that has some kind of, star plate, and having 12 pedals. It is like, star plate with a band on each of the star plate, that one. So it has that part, 13 parts plus 24 hardwares. So during the function analysis, we define, and we deep dive into the part, that what portion is important, and what portion can be, either merged or can be eliminated. So those pedal be included in a star plate itself, so that has eliminated our assembly requirement, and that has eliminated those hardwares. And also by doing the function analysis, and then we do the interaction analysis. So in function analysis, we come up with the parts uh, uh, which is having, some targeted function. So can we merge that function, or can we transfer the function, or can we completely eliminate the function? So if we eliminate, then the next step would come, that who will do the function. That is called the function transfer. So in this case, star plate itself has to do how it will do. So then there should be some surface or something that required to be have that one. So we transfer that function to the star plate itself. So that star plate has to do the function. Next, during the interaction analysis, and uh, then coming to the interaction analysis, we see that what parts having the less connection. So maybe, who has the less connection, can we target that part? So yeah, we have some kind of cover which has having a less connection. Then we thought that cover can be eliminated. Yeah, cover, that cover was mount on a hub. So that is, we thought initially, cover can be, that function can be done by some other part. So then thought, who else can do this part? So that cover was, top cover was mount on hub. So that was the function of that cover, is just to protecting hub from the uh, rusting, say water deposition. So then told, then what about this function? So then we modify, we come that, okay, that water deposition function itself, whether it is required for the system to address, can we do something on that? So then next comes that we eliminate that we change that hub in such a way that there is no water deposition. So if there is no water deposition, there is no cover is required. So there is a hub and there is a cover. So now cover is eliminated and hub is designed in such a way there is no water. See, there is no water elimination. Sorry, water deposition. So then what will happen? Then the design is changed. Then motor is needs to be mounted in that way. So that opens up a new opportunity. So that previously we are mounting motor from the you know in a mounting from the bottom where the person has to hold the motor and then person has to fit. Now, due to removal of those pocket, that motor has to go up. So now, within the same mounting, how we can mount the motor? So then we change the mounting itself, where the motor could be mounted from the top, and over that hub would be mounted. So we change the assembly sequence. Still, the functionality is remains the same. So trees always, uh, follow the functionality. That function has to perform. That is how the part is made, and that is so by addressing one aspect, indirectly we address the another aspect. So uh, that serviceability of motor is improved. So that is we can call intangible benefit what we got. So as you deep dive and addressing all the functionality, there is always the scope to improve or work upon. So this was the one part. The second part, what we did, there is a piece out of this was a drum. So we thought how we can reduce the part count. So in this, by doing this, we have reduced the part count from almost two parts from the pedals, 24 hardware and 12 pedals, 36 part. It is only two parts. One is the star plate, and another is the hub, and one more part is removed is the cover. So that is how based on the what target you define, you will get the output. Uh, the second example I would like to share is about the contradiction. So that that was in a case of same. We have an engine door over which the ladder was mounted. So that door was about 1.5 meter long. The engineering it can be solved by the engineering contradiction or physical contradiction. So both having the same rule. So the target is that the contradiction is that the door should be stronger and yet it sorry the door should be lighter yet stronger. So then the contradiction principle we use and come as the segmentation. So that means where you need a door strong and where you need a door lighter. Then we analyze the functionality and we see only where the ladder is mounted, you would have a stronger section, and where the other section, other half can be lighter. So we divide into two sections. That is a segmentation. By segmentation rule is given. Uh, so that is both the physical and engineering contradiction give us this trees principle, and from that we could achieve 7 kg weight reduction, roughly around 20% of the total weight. And yeah, uh, on the topper side, sorry, I forgot to mention on the numbers. The total topper drum weight was around 80 kg, and new design has a weight of 60 kg. So around 25% weight reduction is done, and that was a two per machine. So uh, it is almost 40 kg, 45 kg. So roughly that one, and the saving was in $700 or 70K, 70,000 K. Volume was about 100 machine. So that was the saving on topper drum. And yeah, those two projects, and plus what we see from these uh, trees gives you the multi-direction. You can't think only on a single direction, that okay, if I want to reduce the weight, you can go for change the material, or just change the design. So it is like whenever you do any changes, it is like a it is like a family. If one part is changed, what about its dependents and family members? So that take care of whole system. The second good thing is in many other processes, or many other methodology, here is used the science more, like in some of the rotating parts, where we can't many times not consider moisture, air, gravity. So those kind of things we you know consider in trees. So that is what is the super system playing the role, and can we leverage from them. So that is what trees will give you liberty. Besides that, I think many other simple example, just recently I can share out of engineering world. Uh, During this Ganpati, we had that roof pandal that is there, which is made up of steel roofs and uh, bamboo and that thing. So the function of roof is to just to prevent the water to come in between the two buildings where the pandal is covering the area. So I just come up with the solution, that how this can be simplify, and yet it could be done very uh, frugal way. So just mount those uh, big what they call third patris in two sides, and from center you can raise with the making knot, so it becomes like a roof, and the water would be go from the side. You can put there the pipe kind of arrangement. So this was the example you can put in real life. The best example for innovation you can see from the household items, that having the single part has a multi utility. The same thing, trees will encourage, not encourage, but give you the innovation. So for us, like after using trees, uh, we have increase on the innovation front, because many of the areas we never touch systems or parts, so which trees enables us to deep dive into those area, and taken care for that one. So yeah, those are the few examples I did. Besides, we currently uh, uh, I think having six batches of trees training, and uh, many other colleagues started using on their project. Yeah. Any question till now?
This is Narayan here, RK.
Yes.
Of course, yeah, you mentioned some case studies. Interesting to know. Of course, you can't disclose more of those case studies.
Mhm.
But yes, do you find any difference between now? Of course, you have gone through this particular journey. You are implementing TRIZ. Your team is implementing TRIZ. Do you find there is any difference from the traditional approach and the TRIZ-based approach? And if yes, what?
Yes. So, that this approach gives us a good advantage. Like uh, previously, what will happen that whatever the ideas coming from the brainstorm or any other ideation, I think, if you work and if uh, it is not defined in a whole way because that is not taken care of the integral system. So in that way uh, uh, for trees how it help when I start that uh, 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 this topper trees project. uh, Initially we have a challenge for the manufacturing. Okay, so what trees tell that target the function. So initially we made that those plate in a such a way so that then we come as a manufacturing challenge that we made the part, we made the concept, but then the manufacturing and fixture cost would be higher in that case. So uh, then we again the modify in such a way that all functionality should be matched and still the manufacturability would be easy. There is no extra tooling is required or there should not be some complex part. So that is the one thing we address. Secondly, uh, by what will happen initially in other methods, only you target the specific things. But here, when you go through the journey, you can think, okay, how the serviceability can be improved. Serviceability can be improved, or maybe you can come, okay, this part can perform the dual function, or the functionality of the part itself can be increased. So those kind of things we achieved here. So we improved the serviceability, we improved the manufacturability, we reduced the assembly time. So those kind of advantage we reaped here. So that was the benefited we get. uh, the other things what in things here, contradiction. So whenever if you see define the system very well and taken care, so the whenever you have the contradiction and you resolve, so you will go to the your goal uh, very easily. So trees will give you the direction. They will say, okay, there is either you use these four principles which will be more suitable for your application. So, and the good thing is that trees is not only about mechanical engineering, particularly. So that you can take the solution or not a solution, but reference from the other system also that we call it like medical industry, aerospace industries, and like that. Am I right? That how the aerospace other industries using the this solution. So how that could be used in our solution. The one more example I can tell you that we had to make the platform. There is a anti-skid requirement is there. So how we can improve the so currently we are using the platform and over that we sticking the anti-skids. So now we thinking that how this can be done integral, so there won't be any uh, more parts, because that will this anti-skid would be after certain period, it will be due to water and moisture, it will have an effect. So then we see that completely there in like a, aeroplane that connecting boogie, they have a surface that anti-skid surface. So those kind of coating you can apply it your location, and that is serving the purpose, because they have using for many that continuous application. So it is always beneficial from other domain. So one more thing is that trees is about innovation. So the trees is not telling that we don't have time to inventing things. So we can leverage what the other industry come across the such a problem, and how that could be we can implement in that is all principles take you through that direction.
Okay, thank you, RK. And a follow-up question from the similar lines. You said that you were working on certain projects, and just to ask you, how long were you working on the project before TRIZ and still not reached a solution? How long were
Okay.
you working on that?
Yeah,
And how
that's
long did it take you for coming up to or reaching to an appropriate, suitable solution after you started practicing TRIZ? So the difference in timelines.
yeah. So actually, uh, frankly speaking, we had, I think, 4 months we spent for the couple of ideation and workshop for the brainstorming and all that. We come up with many ideas, and when we scrutinize, I mean, like not a scrutinize, but to go through the review idea, and that 3 4 months we didn't get that much leverage. Particularly, we had a target of like a 10% weight reduction of these machine, and which was really huge. So conventional way, we want to be able to target these thing. So these 3 4 months means like we haven't generated that much value, okay, of that what is the target. So then we think if this was the pace, we could not achieve by 2 years down the period whatever the target 3.5 ton or 10% of the target. So then this was come at the same time, and we took the training, and we thought, okay, let's try with the trees methodology. So we prepared the old data set. Yeah, one more thing to add. Uh, when we started at that time, we do not have a software because we immediately start implementing after taking the training. So a lot of time we have to spend on Excel and using that one. But now we have that software, so we can that leverage the time. So that is the good thing. Now we can prepare the database and systems and the interaction model. Those could be quickly. So after using these trees, I think within a 4 month, this project we come up that 25% of the weight reduction, and I think that is there. So total weight reduction in 6 months with the two project, it is in a ranging of 120 kg, and on an average it is 22%. Okay, one was a 20%, another
That's great. So probably you before TRIZ you were struggling to achieve 10%, and after TRIZ you could probably achieve 22 to 25%.
was.
That's what
Yes,
you mean to say. Okay, and just to summarize, just to again rephrase, RK mentioned something about software. Software definitely is not mandatory for using TRIZ or applying TRIZ. It is just an aid or probably an thing which probably you can avoid a lot of rework. It just simplifies your work, which is on Excel. That's it. So
yeah,
definitely you can work on trees without the software also.
yeah.
It just helps you, what do you say, simplify your analytical work. That's it, nothing else.
Yeah, because we had to prepare for the whole machine. So
Yeah.
for us, this project was a longer. It's like in the case, strength wise is like that was very much from the we have a liberty that from the front to back. We can go with our constraint. It's like accept the constraint. You can go with this methodology to reduce the weight without affecting much of the capital, much of the things. So there are two things here. That is one thing I just want to mention. Uh, the good thing is that it will give you the radical things. So uh, just to say, once you just go through this function analysis and model, you will able to explore the more area in terms of let's say we have a swing arm arrangement. Okay, we change it to the telescopic arrangement. So that gives us the uh, advantage over that one, because uh, you just explore the new things. Okay, that can be done in this way, that can be done on other way, where we can leverage the functionality, and still the structure would be lighter and perform the same functionality. So yeah, I think
Right.
yeah,
There's a
Dr.
question from Dr.
Prakash.
Prakash Patil.
Yes.
Yes, Dr. Patil, you may please ask. Dr. Patil? Yeah, you may ask your question, sir. Mm, I think we can't hear him. In the meanwhile, anybody else has any question? Because definitely our case got experience implementing. Yeah,
Yeah, I think we have my colleague Mr. Dharmendra, who is also working on the similar line, and I think he has also attended trees events and those college start that one.
Yeah,
So
he was in a Sparkle of
Sparker.
KPIT and he guided the students out there. Hi, Dharmendra. Sandeep here. Yeah.
Sorry, I was on. Am I audible now?
yes,
Yeah,
you're
yeah,
audible
you're
now.
good.
Yeah.
Y- it's nice to see a big community community of trees. And to be very frank, it's my very first experience of sharing this experience, sharing the trust experience. So let me just introduce myself. Uh, I'm Dharmendra Nagar. I'm working for John Deere since almost 3+ years, and my responsibilities are basically over the engine platform. So I'm responsible for debris management. So some of you might not know, like harvester is very prone to debris accumulation, and there are high chances of getting fire if any debris is getting accumulated on the hot surface. So I just took care of that and make sure that through CFD that no debris is accumulating around the heated zone. And apart from that, I'm also responsible to prevent the hot air recirculation, because most of the field what happen, we have a windy situation in which uh, um, the direction machine is running, and in opposite direction we have the wind. So whatsoever hot air coming out of the engine, it actually got rotated into the engine. So that actually impact the efficiency. So these are the two domain I'm working on right now. And apart from that, yes, definitely, I'm also responsible for spreading awareness of stress within the team over here in the crop harvesting team. So second thing, how we come to know about stress. So thanks to Narayan and Shri, they had took our very first session. We were the first batch, and you know like how many batches has done the trust training, seeing the result.
Yeah.
So we are just trying to, like you said, the software is not required. Yes, definitely. So we tried to prepare one template in the Excel, and that worked very well.
Fantastic.
But definitely, software has its own advantage of reducing the
True.
bugs. Yes. So, but yes, anyway, like nobody can feel that if you do not have software, so that's a big resistance. That is not at all. So trust is the methodology. You can include it in the personal life or professional life. Anyhow, there are so many good tools we have. So training experience were amazing, no doubt. The example, live example they took, uh, the climax which she has kept from the starting of the session. He took one of the problem statement, and till the end he uh, run on that problem statement and let us think that what could be the possible solution. So I really like that session. And so where I am implementing Trace in my project. So as soon as I started implementing Trace, so I just gave you the rough output, and within 6 months I came up with the 3 patent which got approved instantly. Like
Fantastic.
team, yes, the stakeholders, they literally like the idea that they don't even care to wait for the testing. They just said you just go ahead and file, and the testing and implementation work we can just do meanwhile. So that was a great achievement. And how trust come into play. So there is one more moral value, or the lesson I learned out of it. So the problem statement which I was having, I was trying to give the traditional solution. So I actually gave the traditional solution because of the time constraint. But what happened? The solution which I provided, the team has forget to put one part on that solution. Like out of 10 parts, they forget to weld only one part in that system. So what happened? That solution got failed, and I just got nervous, like how this could have happened. I didn't know the root cause. Basically, then we have done the CCA. Then I came to the root cause that one part was missing. But while doing that, what I tried to do, I tried to apply the contradiction because I was already aware of the system. So going through CCA and function modeling was not required for me that time. But in some case, like when we are not aware of the system, definitely we should go step by step. But I was already aware, so I applied a few of the contradiction. And as that principle suggests, blessing in disguise. So it actually helped me. Like it says, convert harm into benefit. So it was related to the belt drive. So my belt was breaking and it was damaging the other part around it. And the engine area is so confined that it is having some costly component, cooling core, shroud, variable pitch fan, all of those are running around. So I thought like belt, if belt is already broken, why not damage it further and stop that belt? So actually that was the harm, but yes, we are converting that harm and that breaking of belt into the benefit. So it actually helped me coming up with two solution over there, and it got resolved instantly. And yes, we are under like the testing phase right now. We are preparing the model to test those concepts, and yes, soon we'll try to implement those in the production machines. So that was a great experience of mine with Trace, especially with the principal. So basically, what I mean to say, like even if we don't want to go step by step, and if there are guys who are working on one of the system from so long, so they are already aware of the engineering system very well. They know each and every component very well. So even if you have any problem with that engineering system, we can directly jump up to the contradiction, and they literally help. You just need to form the engineering contradiction or physical contradiction, and we come up with the solution. But the tricky part is, yes, applying inventive principle has took a lot of practice. We come up with some of the inventive principle. I tried a few, but I didn't got succeed. But that principle itself, blessing in disguise. So I just got it. So that was a very good experience of mine. And one more thing, like the tools which we are learning in the trees, they independently have their values. Like for the usually every process have pre-processing, solver, and post-processing. So we usually have that understanding of solving the problem. Like generally, what we do, we try to uh, find the problem statement. We do some brainstorming, try to find the root cause, and we try to implement it. So the same thing we are doing in Trace, but with the very good tools. Like in CCA, we are in function modeling, basically. We are having every component in the map connected to each other and how they are connected and how they are impacting each other. So that engineering system which we form in the function modeling, that actually helps us a lot. So just by seeing that overall block diagram, we can simply say, yes, this component function we can transfer, like we can directly apply trimming by just seeing that plot of engineering system and the connection between the components, how they are connected. So not only in professional life and personal life as well, like if you want to take any decision, you just consider yourself as a component and other family members as the component. And if you are have a joint family, you can consider that as an engineering system and decide like whatsoever decision you are taking and how you are connecting to your relatives, and based on that you can play. And I actually done that. So not only in professional life, personal life as well, I have a very amazing experience. Last but not the least, about the psychological inertia. So I literally like that topic when she has explained that in the training. So it actually hit me quite, because what usually happen with us, like we are just growing in the society where from the starting onwards we are having the constraint of living the life. So that's okay. But what happened after a while, we just get used to it and we just try to think if any problem comes, we just think of the constraint first, like what are the constraint in our mind, and considering those, we try to find the solution. But what psychological inertia is, you just let go, like you just get free of the constraint first, and then at least try to think like without the constraint, you are able to think or not. So that's the practice we should be following. Like I'm the members which I'm training over here and which we are trying to work, we are also practicing the same. Like just forget about the product, forget about the timeline, forget about the cost. What is the most radical solution you can give? So try to record that solution first. It may be possible that the solution which we are giving right now may not be able to implement in the next 2 3 years, but you never know what could be the technology in next 8 to 10 years. So just try to record those radical solution whatsoever you are getting. So the same thing we are doing, and literally this year we have filed 30 plus invention disclosure, and the management is actually appreciating it a lot. So that was quite a learning and training for us. And
That's great.
and yes, the session which we are trying to take over here, we are just trying to simplify them as much as possible. We are just picking up the definition, giving simple examples, so that people can try to understand the function, component, engineering system, and super system. If they are able to understand that, then they can easily play with the function model contradictions and trimming. So most of the team members are up to the CECA right now, and most probably in the coming months will be teaching them about the contradiction, like how they can implement those.
Great. So what I understand from you is now you have started to speak the common lingo.
Yes,
Yeah, so TRIZ is becoming a common lingo in JD now.
right,
Okay.
right.
One thing, Prish, probably for the interest of the other teams, while of course some people jump into contradictions, but we generally say don't do that. Follow the method systematically, right from your component analysis to your interaction metrics, and then cause and effect chain, and then trimming, and then get into contradictions. But at times, I do understand people with their experience do certain things mentally and jump into contradictions. It's not wrong or it's not right. I will not comment on that, but please avert from that particular process because you might miss out a wow solution in this particular journey. So just a tip from my side, don't probably jump into contradictions directly, follow the process systematically. But I do understand people with experience do it mentally. When you said we jump into contradictions, you had probably done something mentally. That's because of
Right.
your experience. So that's not recommended, but then if you can do it mentally, nothing like it. Yeah.
Yes,
So coming back
definitely.
to one question, Ms. Dr. Prakash Patil has posted, can you throw some light on innovative solutions in agri-based project? So probably they have been sharing some examples from the agri-based project only. Any mentioning any specific project? Probably I am not very sure how comfortable RK and Dharmendra would be. So, but in case you are comfortable, you may please share it.
No, definitely we wanted to share in depth. But yes, due to the privacy policies, we are strictly not allowed to share anything in detail. But yes, definitely one of the project which I shared, like we are just getting rid of the conventional guards on the drives. So that is one of the project, and that is actually improving a lot of cost for us on the machine, because like there are n number of drives in the harvester and we cannot cover all of them. We just need to protect the important interface, and that's what we are doing right now. So that was one of the example. And other example is like in hot air recirculation. So what was happening, on the engine platform, now the hot air get recirculated in the intake air system. So we have the application requirement that intake air should not be plus minus 8 degree. It should be at ambient temperature of around 45 plus minus 8 degree. So CECA helped us a lot over there. We were struggling because in windy situation, a lot of hot air is getting into the intake and impacting the efficiency. So there we came up with the solution that the root cause was our styling panel, which we were using, and we just try to uh, improve the panels, because we never thought of like how the far away styling panel are impacting that much. But yes, definitely, you never predict what could be the root cause if you until and unless you just keep on breaking in cause effect and chain analysis. And there are others as well which are in the pipeline. Definitely, if we get a chance in the next session, sometimes after 2-3 months, we'll be definitely able to share those.
Definitely. Definitely. I hope that answers your question, Doctor. And any other question from the team? Anybody? Because I see few academicians also joining in. So a question in the interest of academicians, if they are not asking, how do you think TRIZ fits into academics, and do you think they should follow it? Yeah, Dharmendra, do you think
Okay.
how do you think TRIZ fits into academics, and do you think they should follow it?
Yes, definitely. Like there is no age to start implementing TRIZ methodology. Like from, as I said, from your personal life to professional life, anywhere you can implement any of the tools. So definitely you should be implementing, like even if you have your course structure ready and you are about to give the exam, so I'll suggest definitely you should be going through at least psychological inertia over there, like the fear of exam and what all things you are preparing, whether you have prepared very well or not. So if you just came out of that zone by understanding the psychological inertia which you are usually in before the exams or any of the important project, so that actually helps you clear your mind and align your learnings or study whatsoever you have done in the last 6 months or 12 months. So there is no doubt in implementing it in the academics or any of the projects and the academics.
Great, great. And do you want to share your what do you say, Manis, your team's experience or your experience throughout the implementation of TRIZ in GAD? Any specific thing which you'd like to mention? Were there any obstacles, or it was a blessing from the senior management, hence you are able to do it? How is it?
Okay,
Okay.
you want to answer
Ye-
this?
Yes, I can. You can. So the thing is that, as I said, yeah, from the initial project when I taken up, there was not so much, response, and because they were, I mean, like we were new to the tool, so people were, a lot of, as I said, a lot of constraint come from the manufacturing and design and service and all that. So so trees is not only, that function analysis also. So there is all these surrounding factors, like, previous failure, or what kind of design history. So that all have you have to carry it out. So basically that will, give you the robust things, because you are changing the things which has been designed, in 15 years. So what are the 15 years history that has to be, the current design has to meet, the new design has to meet the current one. So that was initially hiccup. We got some resistance, that why we are asking so many questions, so many things, uh, because it's all about, like, one part has to function. What is its pure function? Whether it does any other function, whether it has, previous history to change, whether it has, uh, uh, what you called, how it has been designed. That is first of all that we need to know. So those kind of things, like, it is a lot of questioning kind of things. So that initially we got some resistance, that what these guys are doing. So believe me, first 3 months people are just thinking, what is these guys are doing. So 3 months we do not have any concept, anything. We just prepared the, data, brainstorming, all information, because here, you have to understand the system very well, and then you can propose the thing. Now, after 3-4 months, we have the data, and then we could, utilize those things, and we come up with a solution which address most of the all tick marks. So that was the good learning. So initially, yeah, you will have some hiccups or some resistance, because that is, absolutely different. It's not a conventional way to go. So sometimes people may think, why you are challenging my design, so kind of thing. But
True.
it is not like a challenging design. It is like, finding the solution. So finding the solution, or maybe addressing the whatever the issues. So as I said, for defining the system, you need a more information. So yeah, for my call on academic, it is a good tool to any see. So maybe you can take some theoretically project on that front of whatever the stream you are, whether you are in a chemical or whether you are in a, mechanical or some domain, and that would be give them initially confidence. So when they go into industry, they just know that these two things. And yeah, and as Dharmender mentioned, it remove your mental inertia. So there's just one example I can give you. We always drill apart from the drill comes from the top, and cheap is again we are removing from the pressurized water and other things. So just maybe if you think about the trees, they said why the tree drill can drill bit set cannot come from the horizontal or inclination, or maybe the part would be upside down,
Hmm.
and the drill would come, and by gravity the chip will fall down, right? You don't need extra effort to remove the chip. Again, yeah, that so it will remove your mental inertia. So, you can think on the multi-direction. So that is the about trees. So uh, yeah, that is the what I think. I did a couple of things in my home project. Some uh, jugaad, but still, let's say mop. Okay, that was very frugal thing. Uh, my I did that mop has to do the spinning, and at that same time the road has to be robust enough. So I did the localizing strengthening with introducing one more sleeve, which will not go toil on the pipe itself. The load will transfer into that outside sleeve, which is having the good strength. Okay, and that mop that lasts for 5 years.
Oh,
It is plastic mop and the steel pipe, and this is a very frugal example that where you need a strength, still your functionality has to meet. It can do the up and down, and those kind of things. There, coming to that innovative solution. So whenever you go, I think we have some restriction on putting the insight on our solution. So just to give you more generic example, we have the topper which would function in one of the or measure of the functionality, but there is still it has a limitation in some of the conditions where the cane is very dense, heavy, and tangled. We are not able to utilize it. Okay, and that give us you know uh, the meal on a hard time, because that green cans, the green leaves, you again have to cut through the system last, and many of the leaves would go with the meal, and so that is the green can is a disadvantage. So we, while designing this thing, we come up with some solution where it could take address those things where the tangle can we could not do. So yeah, I cannot put more insight on it, but yeah, you got the different direction also. So that we parked on that one, we focus on mine one, and once the that drums were done, so that again triggers the different direction where you can utilize the current part efficient way, or it can use that one. So that is the innovative. The other things, you can reuse the part such a way you can eliminate some parts. So that was, we have one stand which was separately going with the machine while transporting. At the same time, we have a brush rail which was using the same way. We removing the brush rail because of the width limitation on the road. So we come up with the things that how the stand can be eliminated. That stand can be eliminated, then part itself has to perform the function, but start part could not itself do the function that in our cases. Then who else can do? So that brush rail also we at detaching, can the brush rail do that one? So brush rail has a brake, so we designed that one of the project that one. So brush rail itself would be there. So when you need a brush rail, at that time you don't need this stand, so that the brush rail itself doing the function of the stand, and the separate stand is not required. So that kind of thinking and methodology would come. So you think beyond regular
Okay.
way.
Thank
Yeah.
you.
Okay.
Okay. So we have 3 more minutes. So before we close down, RK and Dharmendra, a piece of advice what you would like to give to the participants who are attending it or would listen to this particular session later on, quickly within 2 minutes or 1.5 minutes. So we have 3 minutes left. A piece of advice based on your experience.
Uh, the only one thing I would like to share, like which hit me the most, is the psychological inertia. I think the environment which we are working right now, we should try to take a step back, come out of that environment, and try to think differently. So I literally like that topic a lot, and I have I have implemented that in my personal and professional life. So we do have a lot of component. We just keep on iterating those, optimizing those, but just do one thing, just leave all the components there and try to take a step back. Like why we are just playing with those components. Are they even necessary or is there any other way around? So instead of just getting lost in the complication, I'll say just try to stand out of it.
Great.
Take a time, breathing, remove your inertia, then start working from the scratch. So I literally like that. One more thing, which I missed, like the spreading, we are spreading awareness within our team. Like you already know Ajay. Ajay is supporting us a lot,
Yes.
and Triz, and he is always on the top, like whenever we discuss about Triz or any project. So we took some offline classes as well over here, and we started spreading awareness with the term Trizzinking.
Ah, great.
So we have traditional thinking, creative thinking, analytical thinking, lateral thinking, systematic thinking, design thinking, lean thinking. Like there are so many are already there in the market. So we just decide let's start our own and let's start thinking.
Great. Great. RK, any piece of advice from your side before we close down?
Yeah, means like just to give you advice. So once you go through this process for the treating, it will attract you because the thing is that you can see the surroundings. So maybe as I said, don't focus on only on the small circle. The solution may be surrounding it, whether it is a nature, whether it is a different industry, aerospace industry, or chemical industry, or based on your that thing. So that is the good thing that some that is what I like about the trees.
Great, great. Thank you, RK and Dharmendra, both of you, for sharing your insights. So I think what we can conclude is come out of your psychological inertia, come out of your comfort zone, and the most important thing is let and encourage all your team members to speak the common lingo, and definitely have persistence and patience so that whatever you're learning will start showing results over a period of time. Because end of the day, trees is not a magic wand. So you need to think. It is not instead of thinking. So it is just an enabler or an aid to think better. So end of the day, human being has to think. So I think thank you once again. Thanks for your time. And maybe we will invite you once again for the next Twist Talks, probably after a couple of months later on. Okay. Thanks, team. Thanks, team, for joining this particular session. And in case you will want to just ask anything informally and these people want to wait, we can wait and continue. But then it's 5 o'clock, so it's Friday. I don't want to be the bottleneck between you and the weekend. So let's wind up for the day and have a wonderful weekend, team, and God bless.
Thank
Thank
you.
you.
Thank
Thank
you,
you.
everybody.
Thank you.
Thanks.
Thank you,
Thank
everybody.
you.
Thank
Bye.
you.
Thank you.
Thank you. Thank you.
And stay tuned for the next Thriz Talks. That would be on 30th of September, and that would be 9th Thriz Talks. So we'll be messaging you about the details who would be the speaker out there.
Yes. Yeah, that will be our 9th chapter.
Okay.
Okay. Thank
Yeah.
you once
Thank you
again.
all.
Thank you.
Bye
Have
bye.
a
Take
good
care. Have
weekend.
a wonderful weekend ahead. God bless you all.
Thanks, everyone.
Thank
Bye.
you.
Bye. Bye.